Okay, let's do a quick introduction to transition metals. The main ones you've got to learn in terms of colours are iron 2, copper 2, iron 3. Aluminium 3 isn't really a transition metal. It's not in the transition metal block. So the definition of a transition metal is that it needs incomplete 3D orbitals. The 3D orbitals can, the electrons can become excited or promoted. What that means is they can move between the 3D orbitals and in doing so absorb visible light. And as they absorb visible light, the remaining light that's either transmitted through the sample or reflected back from the sample then shows whatever colours are remaining. So iron 2 is green, copper 2 is blue, as in copper sulfate, iron 3 is yellow, aluminium is colours. It's not a transition metal, so it's not going to have incomplete. It's going to have not going to have incomplete 3D orbitals, and therefore it won't be able to absorb light. What happens when you add sodium hydroxide? Well, we get solids. Now, if you look at iron 2, FeH2O6 you can get 6 water ligands around an Fe, around anything really, because waters are small, so you can fit them around. The ligand is where there's a coordinate bond where both electrons are used from the water molecule, from the ligand, to form a covalent bond, a coordinate or a dated bond, where both electrons are coordinately bonded to the central metal ion. That gives the number of coordinate bonds then as something called a coordination number. So if I look at FeH2O6, 6 water ligands can fit around the Fe. They form coordinate bonds by donating pairs of electrons from the ligand into the covalent bond or the coordinate bond. And it's coordination number 6, which is the number of coordinate bonds, not the number of ligands, the number of coordinate bonds. It's green, but what actually happens is when it's Fe2+, because water has no charge, Fe2+, if it's going to form a solid, the solid has no charge. So if I add sodium hydroxide, it's going to make a green solid, as it does. I need to replace 2 of the waters, 2 of the 6 waters, with 2 OHs, because OHs are minuses. So Fe2+, no charge on the water, 2 OH minuses leaves no charge, and therefore I get a green solid. It oxidizes, by the way, and turns into iron 3 in the air. But let's have a look at copper. Copper does the same. 2 of the waters are replaced by 2 OH minuses. 2 OHs, each minus charge. Copper, Cu2+, no charge overall. It's a solid. It's a blue solid. Fe does the same, but this time I need 3 OH minuses. 3 OH minuses to balance up the Fe3+ and leave no charge left over, and I get a brown precipitate of iron 3 hydroxide. Aluminium does the same, but it's going to be white. Al3+, group 3 after all, Al3+, replaces 3 of the waters with 3 OHs, OH minus 1 each, to leave no charge overall, and that's why it's a white solid. What happens if you add excess sodium hydroxide? No change. Apart from with aluminium, the white solid gains another OH minus and becomes AlOH4. It gets a minus charge overall now, because 3+ from the Al, 4 OH1 minuses would leave a minus charge overall, and it dissolves and forms a colourless solution. What happens with ammonia? Well, ammonia is strange because most of the time ammonia forms ammonium hydroxide, and like sodium hydroxide, it can make OHs. So it makes NH3 and H2O, it makes NH4OH, ammonium hydroxide. So it acts like sodium hydroxide and makes the same things as sodium hydroxide. However, when you add more of it, sometimes only with copper, the ammonia ligands can replace both of the OHs and 2 of the waters, and it can form CuH2O2 with 2 water ligands and 4 ammonia ligands, and it forms 2+. Why is it 2+? Because the water and the ammonias have no charge, and the Cu is still 2 plus overall, and that's a deep blue solution. What happens with sodium carbonate? Sodium carbonate makes carbonates, FeCO3, carbonate is CO2 minus, Fe2 plus CO3, FeCO3, 2 plus and 2 minus makes a green precipitate, no charge. Copper carbonate is a bluey green precipitate, Cu2 plus CO3, 2 minus. Now, iron and aluminium, they're acidic. They withdraw electrons towards themselves along the coordinate bonds. So they're Fe3 plus and Al3 plus, and they withdraw electrons towards the transition metal ion, because the 3 plus, Fe3 plus and Al3 plus, they withdraw electrons towards that plus charge, and it breaks some of the bonds in the water. So some of the waters, instead of being waters H2O, become OHs and release H pluses. And with the carbonate, that can make carbon dioxide gas. So with Fe and Al, it turns some of the waters into, 3 of the waters, into OHs and releases H pluses. So it makes the brown solid and the white solid and releases H pluses, and that's acidic. And with the carbonate, it makes bubbles of carbon dioxide, as all acids do with carbonates.